The first thing I want to show is related to a new, very exciting feature in Livebook, which is a new remote runtime. All right, so imagine like I have this notebook here, which does some machine learning stuff, and I don't have GPU on my laptop. But when you run like some heavier machine learning workload on some experimentation, having GPU to handle the computation makes things much more faster. And so what we did is we added this new kind of runtime, which you can configure under runtimes, and you can pick fly machine. And here we can grab a token from Ply. I have a preset configured here, so I'm just going to select that. All right, and here we can customize like the region, the number of CPUs. We can even use multiple GPUs, and we can have some volume for caching. So I'm going to connect to the machine. Hopefully it's going to work. Let's see. And underneath what it does is basically like talks to the Fly API to spawn a new machine with the GPU and all the resources that we requested. And then we establish like a connection over Fly proxy to the remote node, and we talk over a long distribution. This is actually like a very interesting sort of part, the implementation side. So we can talk about it later if you're interested. Just let me know. But now we're sort of having this runtime, so all the code that we execute actually runs in the cloud on a fly machine, right? So I have the dependencies cached on the volume, so we don't need to wait for that. And just to see that the GPU actually works, let's try this model. I also put together this small example with a new feature in Bumblebee, which we added recently. It's a new kind of serving for specifically for translation. And the motivation was actually like this particular model from Facebook, which allows you to sort of translate multiple languages between each other, right? So it's not like a model specifically trained for a pair of languages, but rather for like 100 languages, or actually 200, I believe. And you can sort of at runtime specify which pair you want to translate between. So what we do is we load the model and the other bits necessary over here, and then we build a serving, right? And we start the serving as a process. One important part is that we specify compilation options, which basically tell the serving to compile the model up front while starting the process. And so then it's going, the machine learning model, the serving is going to be ready to accept our requests. You can see some logs coming from the GPU, right? So it's been correctly loaded, compiled, and now we can just use the serving API to ask the model to translate text for us, right? And yeah, this is Polish. I can confirm that, and we can actually specify different language pairs. So let's do French, right, or maybe Spanish. Yeah, you can see that the model is like very snappy because we're running on the GPU, so just like a couple of milliseconds, and we can change the language pairs while still having the same model running. All right, so all of this is running on the Fly GPU. Let me just see. Okay, yeah. So all of this is running on the GPU on Fly. But this is not the end. So this is a very major feature. And by the way, you can also do the same with Kubernetes. So if you have like a internal infrastructure that you use in your company where you have GPUs available, you can actually configure. You can actually like use Kubernetes, and it works basically the same way. I don't have Docker started, so that's why it shows this warning. But yeah, so now that we're inside the Fly infrastructure with this runtime, this machine, there is another cool thing that we could do, which is spawn more machines to sort of do heavier workloads, right? There was actually like a recent keynote on Elixir Conf US from Chris Pickard and Chris Granger, where Chris Granger like trained 64 neural networks in like concurrently, so 64 machines with the GPU, each of them running a separate training. And so just to give you an idea how this works, let's try the new section. And conveniently in Livebook, we have the smart cells. So here we select Flame Runner, and we can configure all the parameters of the additional machines that we want to start. So let's say we want to have exactly one machine. We can bump the specs a little bit, maybe. Yeah, we don't need a GPU for the demo. So what is it going to do? So okay, let's take off the back because maybe people are not like familiar with Flame. But what Flame does is allows you to take your existing, for example, Phoenix app or Elixir app, and as part of the app, you can just wrap code, like a specific code which requires like a lot of CPU or perhaps GPU. You can just wrap this code in a Flame call, and then you need to configure a Flame pool, which sort of configures like how new machines get started, and it has like backends for Fly and for Kubernetes. All right, so here we are going to be using the Fly backend, and this smart cell basically starts the pool of machines. Normally, you would put this under your supervision tree, and yeah, and what it's going to do is that any code that we wrap in this Flame call is going to run on a separate node, which we can actually guarantee, you can see by inspecting the node. All right, so let's see. And you can see that here is our runtime node that we are executing on. And this is a Flame node spawned for us, and we can also see it here, right? And so the cool part about this whole thing is that now it actually synchronizes all the dependencies and all of the modules. So like if we do a new module here, right? We can totally just call the module here, and Flame is going to synchronize the module on demand. And like if we make a change to the module, you can see that this cell is marked as stale. And if we evaluate, Flame is going to synchronize the module code and execute the new code. And all of this happens on this other node that we've just spawned, right? And just to sort of prove the case, you can use the library that we have installed, and it all like transparently comes back and forth. So yeah, this is very exciting. It enables like huge machine learning workflows when you can like spawn a lot of machines with many GPUs and then parallelize the work. If you want to see like more impressive examples, there is the keynote. Let me see. I think it's this one. Let me put it in the chat. So yeah, you can totally explore that. And let me see if you have any comments, questions at this point. Oh yeah, you already you already sent the link. Perfect. Let me just see comments. Yeah, it is being recorded. I'm recording, and I believe it's going to be uploaded later. Okay, so Goose, you asked where is the runner atom defined? So smart cells in Livebook, they're basically just UI that generates code, right? So we configure the runner, and you can see the runner name here. But if we inspect the underlying code of this UI, you can also see the name Atom being specified here. So this is the name that we would use later for our Flame calls. Could run Llama CPP? I mean, technically yes, because NX serving is like an abstraction over basically like any computation. It's mostly meant for NX computations, but it actually doesn't require it. It just like requires that like the input is transformed into tensors. But I believe what you could do is have the input of a tensor and make the serving computation call into Llama CPP with like the whole batch, and then it would use this abstraction and everything should work fine. And you could actually put serving on a Flame. It requires uh, a little bit of steps to need to go through, but I believe like Chris actually showed a way to start a serving in the keynote, so check that out. And yeah. How does how the code starts? I assume you mean the flame runner. So you can configure the number of instances that you want. If you put minimal instances to be 0, then it's going to scale down after a period of inactivity. But if you keep like you can keep always like one or multiple instances warm, and yeah, and then whenever we do this flame call, it's already running, right? And it also auto scales. So the concurrency here means how many concurrent requests per the given machine are allowed at the same time, however many flame calls. So if it goes over, oh, I'm changing. So if it goes over the specified amount, is going to start a new machine as long as it's still available. And yeah, this way that's how it scales. Oh, so what did you? Well, it's kind of specific to Livebook in this case. So please clarify if you mean like in the Phoenix app or Livebook. In Livebook, what you could do is load the model first, and then when you do the flame call, all the parameters are going to be copied to the other. Yeah. Okay. Let me go back a little bit. So Kishitron asked how did the idea for Livebook came to be, and so yeah, as I mentioned, it came as part of the NX effort. So when NX was sort of starting up, uh, Jaws and Sean, like the maintainers, they figured, oh, we will need something like Jupyter, right, to do a machine learning exploration, and so that was the original idea, and at the time, like so the we Jose get to know me and I get to know Jose through a pull request on XDoc, and so he emailed me like, "Oh, are you interested in like working on this new project, which is a live view?" And so that's how it started. And the first prototype we I think had in like four months, or rather the first version, and it was presented. I don't remember the conf, but yeah, that was the point, and from that point we just kept developing new features. In macOS, how do you open a LiveMD file? So if you use the desktop app, I believe like it registers a LiveMD extension handler. So then LiveMD files should show up with the Livebook icon, and when you open, it should just open in Livebook. But that requires the Livebook app, which is sort of more integrated into the operating system than like Docker or the regular Phoenix deployment. Yeah, so feel free to keep the questions coming, but since I think they're none at the moment, I'm going to show second thing. So let me just go back to the screen. So I mentioned this chat here that just keeps streaming all of the messages, and this is a Livebook app, which is actually like super simple. I can show you here. This is all of the app. This code is just, yeah, this is not relevant. So this is the code I put like in the DevTools on the stream page, which basically like looks at the text whenever there's like a new comment element added, and then it posts to a localhost address, right? And basically like all of this code here that you can see is just exposing this localhost address. So this is another feature which is new. Well, not that new, but like relatively new to Livebook, which is Kino proxy. And what it allows you to do is register a flag handler for certain URLs. And if you look at the docs, let me just start install dependencies, and yeah, we can see the docs. So we can see there are a few URLs which are being handled by Livebook and proxied to the notebook code. So when you register a handler using Kino proxy listen, and a request comes to either the session path, or if you deploy it as an app, if it comes to the app directly, we can handle the request. So in this case, I receive a message and just append it to a frame. And right, and so this is just like a regular session, but what we can do is like just deploy it as an app, and then it runs this, and there's like nice nice UI, and here we can see the URL. So yeah, that's basically it. I found it very convenient just to make sure I don't miss any comments. No, there's no JavaScript at all. This is just a Markdown cell with JavaScript snippet code, which I put to sort of remember the code to paste to the DevTools. But yeah, that's it. Yeah, so feel free to ask me in the comments, Livebook related or Bumblebee related, anything NX. I mean, could be anything really. As for quantization, so I'm going to share an article from Sean. Let me just go here. Going to paste. So Sean recently wrote an article about like the next steps for Bumblebee and Axon, and one of the part is quantization. So Axon on the latest release has a new module, Axon quantization, and it allows you to take a model which is not quantized and quantize it. So it changes the model itself to use quantized layers, and it also quantizes the parameters. So uses like a lower resolutions like integers to store the parameters, and this reduces the memory usage quite heavily. But currently you need to load the model first, the full model first, and then like apply this quantization. There are like a lot of techniques of quantization, and this area is still like being sort of developed. So we still like to catch up with that. But one of the ideas is that we would allow like Axon to load the some of the quantization formats from Hugging Face. It would probably be like the responsibility of Bumblebee, but you would like load the quantized files, and yeah, it's not supported yet, but that's something we should address in the future. And yeah, that's pretty much it. You can go through the whole article if you're interested in like details. Next one for Livebook. So we are developing like Livebook Teams is currently in beta, and we're going to like be launching it somewhat soon, like the full version. And so that's kind of the main focus around now. And if you're not like familiar, Livebook Teams basically brings features useful for teams, like teams of developers using Livebook. So it's like sharing secrets, sharing file systems, and then we also have like this new feature where you can run a Livebook server, right? Like a agent instance in your own infrastructure, and then you can do one-click deployment from your local Livebook, and the deployment goes to the Livebook server instance on your infrastructure. And so this way, you can have like Livebook app that accesses your database because it's like in your infrastructure, so you have access to all of the private network available. And so you can build like dashboards for your company and internal tools. So yeah, we're still developing in this direction. There are a few other open issues in iBook. We don't have, like very strong priority at the moment, but yeah, it's still being worked on. Mm, yeah, so I don't know like specific people to that use live in production, but there are people that are using the Livebook beta, using the Livebook Teams apps, right? And yeah, other than that, like I guess like a lot of people just use Livebook for day-to-day development. Oh, so yeah, you meant for ML exploration in product. Well, yeah, I don't know if like they use for ML exploration in production, but well, for sure, like Chris Granger, who had the keynote that I linked, uh, they are like training their own models, and they're like using Axon and NX, and so they're using like book that for sure. I guess that's the closest that you would get for yeah for this one. Ooh, how do Livebook apps work with Finnic playgrounds? Well, so like you can't really have Phoenix Live based UI for a Livebook app. But what you could do is, I guess, like use the Kino proxy. Uh, you could like use Phoenix to handle some requests, but not really like Phoenix Live. So Phoenix Player and like you can use, uh, in your Livebook for easier development, the same way you would do like in an eScript. But yeah, unless you like render it in an iframe inside the Livebook, but I think like that's a little bit too much for only. Roadmap for new Bumblebee models. Yeah, so like there's a lot of development, so we try to catch up and sort of add support for the new LLMs at least, like when they come out and they become available in Hugging Face transformers. We try to address if there's like a new configuration because the models that get released they're really usually very similar. So for example, like Llama, it's been mostly the same model architecture since the first version, and there are like some just new additions supported that we need to handle new configuration and just a few lines of code, sometimes to support the newer checkpoints. So we try to do that, yeah, quite rapidly, but like also feel free to open issues if there's like a high demand for a new model. Uh, yeah, and also regarding steps to add a Bumble model, let me just share a tweet. Uh, Yeah. So there is a tweet from Sean which like outlines the steps to sort of try adding new model. But basically what it boils down to is try to find like somewhat similar models. So if you're adding like a text model LLM, just find a similar one like Llama or Mistral in the Bumblebee repo, copy that, and then find the implementation in Hugging Face Transformers, which is the Python library which we sort of mirror in Bumblebee, and then you just want to have Elixir implementation that does the same as the Python one, and you can inspect intermediate values to sort of debug and see if they match. That's basically it. But if, yeah, the details are in the tweet, so feel free to also look into that. Okay, let me just scroll a little bit. Oh, whether Livebook requires the latest Elixir version. Um, so yeah, for the attached runtime, you generally want to have at least like the same Elixir minor I think, because there may be some incompatibilities in terms of like code evaluation. But what you can actually do is use the remote cell instead of the attached runtime, and this is going to be more compatible because like we don't sort of send the intermediate code representation like abstract code representation, but we send like strings. Yeah, so yeah, I can just like show quickly in case people are not familiar. So in Livebook, let me just start a new node just to see. Okay, so let's start this one. Okay, we can define a module just to see that we have a remote node with some code, right? And so now if we go into Livebook, there are two ways that we can talk to this node. So the first one is going uh, to start an attached runtime node, right? And here we could specify uh, the node name, the cookie, and now sort of everything that we run here is going to be executed in the context of that node. So we should be able to invoke the function, and you can like even see, we get completion for the functions because literally like we are inside that node. However, there is like a restriction that it needs to be the same Elixir minor. So here, since I'm running on Elixir 1.17.2, it's going to tell me, oh, it should be like around the same version. However, what you can also do is use the regular Elixir standalone, and instead of running the code directly, we have this smart cell called runtime execution, which is going to install Kino, and here we can put the node name, the cookie, and we can run any code here as well. So I did something wrong. Okay, yeah. So this is going to run an RPC call to that node, and if we inspect the given code, you can see that actually like the code is being encoded as a string, which is going to be like much more portable across the Elixir versions, and then like, it doesn't really matter if the node is running an older Elixir and Erlang version, and it should still work. So basically, like if you want to communicate with your app, this is kind of, I would say, like the preferred approach. The attached runtime gives you maybe a little bit more direct access like to the system, but really the remote execution cell does most of the handles most of these cases that you would need. Do you know if there are any features in Jupyter that Livebook does not? Uh, I never like did that heavy comparison, but we certainly have like a lot of features in Livebook that Jupyter doesn't have. On the contrary, I can't really speak because yeah, I actually like, didn't use Jupyter that much other than like the basic stuff. Yeah. Mhm. Actually, well, okay. So somebody's asking about precompiled XLA and compatibility with CUDA. So the precompiled binaries, they are precompiled with like a little bit older version of CUDA, so like 12, 12.1, which is like in the README, but it should be like compatible with any newer version of CUDA. So like uh, if you want to use XLA, you can install the latest CUDA, the latest QDNN, and the binaries that are precompiled for EXA should still work, and everything should just work as fine. Yeah. If visual LLMs are supported, so no, we don't really. At the moment, doesn't support don't support visual LLMs. So I assume like you mean LLMs that take input or output images as input or output. And no, the so images model that we have are more like image classification, and we have like image generation, image description, but not really like LLM. Those multimodal ones, not yet. And yeah, I think there will be a new type of serving. Pretty sure, yeah. If you launch a Livebook app when connected to a remote runtime, where does it run? If you launch. No, okay. I'm not sure if I get the question right, but like if you do a remote, so Livebook app is always going to use the standalone runtime, right? So like just a new Elixir node running on this given machine, and if you want to communicate with some remote nodes in your application, for example, to extract some data, you can use the remote execution cell that I just shown, right? So you could connect to your Elixir application node, and you could use like your regular Elixir functions to fetch some data, make some SQL queries, and then show the UI in the app. Yeah, that's feel free to like clarify the question if that was not what you asked. Do we have Livebook wired to any production apps to debug? Yeah. So Livebook apps is actually, so we have Livebook apps in the Teams product that we are building, and so we have like a regular Phoenix server, And so we have some some Livebook apps deployed that are connecting to that Teams instance, and they're reading some statistics like about how many users sign up, this kind of data, and they're showing sort of charts, metrics. So it's basically the dashboard. And also you could use Livebook to like directly debug an application the same way that you use a remote shell in just in AX, right? So I can write, for example, my Phoenix app and then connect to it for inspection. Yes, precisely. You can run your Phoenix app as long as it's a distributed app, right? So it's a like name and cookie, and it's accessible from wherever it's your Livebook deployed. Then yeah, you can do it. And one thing which is like super cool is that like if you're using Fly and you have a instance running somewhere in Fly, you can then use WireGuard to basically like be in the Fly network, and then from your local Livebook instance, you can just directly connect to the application node and inspect it however you want. But in other cases, you could, for example, run Livebook directly in your infrastructure so that it has access to your Phoenix app. All right, and locally, obviously, you could do that just starting a node with the name and cookie. Any plans for new language support? So possibly we are like discussing some support for Python, but not like in a way where we'd have like an entire new runtime for Python, but rather as Python integrated within Elixir. So kind of the same way that we have Erlang cells, right? And they are sort of compatible with Elixir. Let me just show you because it's easier to show, right? So by default, like everything is Elixir cells, right? So we can define variable, but we also have this way, the option to use Erlang, and the way it works, it uses all of the same runtime, all of the same evaluation, and we automatically transform all of the Elixir variables into Erlang, right? So in Erlang, like the variable names are uppercase, and so you can see that it's compatible with each other. And if we like assign a new variable, we can access it in the Elixir. Sorry, let me just change it back. We can directly access it in Elixir back. So there is this like interoperability. And one of the ideas that we have is like to have basically a Python cell which you would be able to sort of shell into out of Elixir to maybe use some library for scientific computation, which is not available in Elixir yet. We are not like entirely sure, but we have a pretty solid idea of how we would like it to work. So that's something we may explore in the future for sure. When building smart cell, is there a style guide or predefined components? No, so we were like I was considering sort of making a package with components, but I think it's like a little bit maybe too early because maintaining a UI component package is a little bit can be a little bit like a lot of work if you want to grow it and have proper documentation and stuff, and also it like forces the user to use a specific framework. And there's like for a longer period of time where like figuring out how exactly we want to write a JavaScript. So we actually started with Vue because it didn't require compilation, like transpilation. And in the past, we were sort of going into the direction where, oh, we just write the JavaScript directly, use CDN. So there was like no this compilation, there wasn't this compilation step. But over time, there were like, we did cover basically like different trade-offs. And what we do now for all of the Kino components and some of the Kino libraries is that we use React use bundling. We even have like this library Kino bundler in the Livebook organization, which sort of streamlines the process of transpiling all of the assets with Tailwind and React into uh, into compiled assets. And as for like any kind of predefined components, I guess like at this point, the best part is to look at Kino or other packages, and sometimes there are components that we use and they are encapsulated. So for like input select, but there is nothing like officially out there yet. So maybe that's something we will do in the future if we are sort of like happy with the component that we have. Are there any performance comparison between NX and Python. I'm not aware of like any specific ones. Uh, like so on a general note, like both Elixir and Python, it uses some lower level machine learning like compiler, right? Something like written in C. And so on the surface level, the performance like should be basically, matching. For Elixir, for NX specifically, we have like the Torch X backend, which matches Python PyTorch, and we also have the more popular EXLA backend and compiler, which matches the JAX in the Python ecosystem. And the cool part is that it allows you to like compile def ends into standalone computation, and they're all heavily optimized. So in this regard, like it should be pretty similar to Python. But obviously, like in some very specific cases, like more recent modules, like some maybe optimization. So for example, when running LLMs, there is like this very specific part of the language model which is called attention. And for example, when using PyTorch, it is very popular to have like a custom GPU kernel for that particular operation, and it improves the times on the GPU. So and like currently we don't have ways in NX to sort of plug in your custom written GPU kernel, but we are also exploring some things in this area. So hopefully we can bridge the gap at some point also. Yeah, but in general, like on a surface level, there should be no differences. But for some specific models, then yeah, then there could be differences. I think like the main difference would be for training, because there are like a lot of optimizations in Python, and like training is basically its own sort of sub area of machine learning, and it requires like a lot of libraries. So far, we've been mostly focused on inference to enable people using like having Elixir apps to use machine learning to like do machine learning and bring existing model into the apps. But we are going to definitely like explore training in the future, and uh, especially like the this distribution, we could do some pretty nice things in that regard also. Again, as shown on the keynote that I linked before. How NX serving works. Okay, yeah. So that's interesting. Uh, yeah. So okay. So let's sort of give more context for why you would need a serving. When you do machine learning, you have the model, right? And you put some input into the model, like the model runs and gives you some output, right? And if you did that for each user, like individually, right? So let's say it's an LLM, right? It gets some text input and produces some text output. And now the thing is that if you did it like separately for each user, uh, the GPU would be underused, because the GPU is very good at parallelizing work, if like especially if it's independent. So basically, if you have computation for one user and computation for like four users, it could be basically the same time for the GPU, because it can just parallelize. Uh, so what you want to do in like production use cases is have batching, right? So you have like some process, some server where multiple users send the requests. All of the requests are batched together into like a group. Uh, they run on the GPU. You get like all responses for all the users, and you distribute them back. And this is exactly what NX serving does. And how it works underneath is that when you start NX serving in your supervision tree, we start a process, right? Like basically like a gen server. And then when you call NX serving batch to run with the user input, we send a message to the process, and we wait for like a small window of time, like 100 milliseconds, or until we have enough of the inputs, right? So you can configure like the batch size. For example, if you set batch size to 4, we wait for 4 users to send us inputs. We run the computation on the GPU, we get the results back, and the gen server like distributes the results to everybody. And NX serving also works almost like automatically in a cluster. So if you call NX serving by name, and the NX serving is on a different node with under the same name, the batch to run is actually going to find that other node and do the like this distributed call. And if you have multiple of those nodes, we're just going to load balance randomly to different servings. But yeah, it's basically this principle where NX serving is a process and it takes care of the batching and running the model predictions. I'm currently not working on a Livebook course, no. Where are the best place to learn NX? There are a few articles. I think like Sean wrote an article on the Docker blog a few times. If you're like specific, well, I would say like the best resource right now is the Sean's book on machine learning from Berkberg. And so just give it a try. It covers like all the NX basics and then goes through Axon up all the way to like Bumblebee running some models. It's like a very thorough explanation. And even if you have like zero knowledge about machine learning and neural networks, it still sort of guides you through all of the steps. It has like very nice sort of analogies to give you an intuition about it. So I would definitely like recommend this as a place to start. But if you want to like just give an extra try, you can just start with NX docs and maybe find some articles. Yeah. I think you maybe think about diffusers. Yeah, so we also support tiny part of diffusers in Bumblebee. So Python has transformers library and diffusers. Both of them like work kind of the same way in the way they like serialize models, load models. But diffusers are specifically for image generation, video generation, like the diffusion models. It's such a huge area that they like branched out into a separate package. And in Bumblebee, we support stable diffusion, the first version that came out, and then some updates. But at some point, we didn't have the bandwidth to sort of keep chasing the state of the art because I like the diffusion is basically like a whole other area that develops very rapidly. So obviously pull request welcome. But yeah, it's just a whole separate thing. Oh, about the bitrate, we could increase, but I don't want to lose the chat. Well, I have the chat backed up. Hold on. Let me just scroll and see if there are more comments. Yeah, for quantization, like there's still work to be done, for sure. Especially like even if in Python there's like a lot of quantization strategies. Llama CPP is like very elegant way, because it solves sort of very specific part of the machine learning models, which is like the LLMs, and so it sort of inherently incorporates all of the state of the art techniques and yeah. But we are yet to catch up with some of these. Kino using WebRTC. That would be possible because like you can, in Kino you can define a custom outputs using Kino.js and Kino.js Live, and there you can basically write any JavaScript and also send binary payloads. So I think it should be possible to have like a Kino which is a streamer and a receiver. But yeah, if somebody wants to build it, that sounds pretty fun. And does next survey account for the length of individual inputs? If one input is two words and another is two pages, are they batched together? Oh, yes, that's a really good question. One thing with EXLA and like XLA in general is that all of the inputs they sort of need to have they need to have a known length. So we always pad to a specific length. And so if you use like a little bit more dynamic framework like PyTorch, if you get input with like 10 tokens and input with 2 tokens, they're going to just pad to 10 tokens, right? And run that. So it's always like the maximal of the input. But with EXLA, when we want to pre-compile the whole model up front, we need to compile for some specific length, right? So like if you compile for 200 tokens and the inputs are 10 tokens and 2 tokens, we are going to pad both of them to 200 tokens, right? But still, it like could be much more efficient in the processing because it like the whole model is compiled. So there are like trade-offs, but in general, like compilation is still worth it. But we have like this very nice feature in Bumblebee where, well, let me just show it because we actually had this notebook, right? Notebook here. So here you can see that we have like the serving for translation, right? And all of the translation inputs, they're going to be padded into 100 tokens, right? So yeah, like however many this is, like 10 tokens, is going to be padded to 100. And one thing you could do is actually generate a few versions of the serving, not even the serving, but rather but the model compilation. So what we could do is have this, right? We can specify a few different lengths. So you could do this, right? And then what happens is that we still start a single serving process. Sorry, we still start a single serving process, but we are going to compile the model, a variant of the model for each of these lengths, right? So it's going to be like 4 variants of the model, and obviously, like normally, we would also have like a bigger batch size, so we can get more inputs at the same time for the processing. And so now, if we get requests for, let's say, if we get requests for like 10 and maybe 67 tokens, right? We would find the smallest length that sort of covers both of them. So in this case, going to be this one, right? We would put the inputs to this particular length and use that model variant. And if we get like models like 10 tokens and 20 tokens, they're going to just be padded to this one. So yeah, we are basically like grouping the computations. Oh, so sorry, maybe hold on. Maybe it wasn't clear. Like we're going to group by the sequence length, right? So this one would get to the, yeah, I probably explained it wrong. So this one would be padded to 16, and if we had like 67, it would be padded to 256, and each of them would run separately, right? But if you have like a lot of requests coming, then for example, you can imagine we get this, and then we get a request with 12, so we're going to pad to 16, and then we get a request with 100, so we're going to pad to this one, right? And after a while, like after the 100 milliseconds or however long we wait, we would take this group with 16, run the model, distribute the results, and then take this group with 256, run the thing, and distribute the results. So this way, like we are sort of not being penalized by somebody using a longer input, right? We are just grouping, and there isn't really like a cost to doing this because the parameters are being reused, and we have a single serving. So this is like a pretty good thing to do if you are like running a text model. Yeah. How would you have only one Elixir instance per cluster? Yeah, so you could deploy a whole separate application with like just the serving and then use the distribution. I'm thinking if you could use an umbrella and deploy each application to a separate node, right? And then like one application in the umbrella would have the serving, and the other would just be a regular Phoenix app and would communicate over distribution. That would be another way. But it's kind of like up to you. How do you do it, right? You would also conditionally start the serving, uh, right? Conditional start the serving. But in most cases, like if you actually want to like scale, it makes sense to have the web part of the app separate and the machine learning one separate, because like the machine learning one doesn't really it doesn't make sense for it to serve web requests, right? It's just the GPU, so let's use all of that bandwidth. So yeah, I think umbrella would be one option, and the second would be just having a separate deployment of the app. It could be the same app, kind of the same way that Flame works, right? Where in your application supervision tree, you have a conditional, and depending on the configuration, maybe like an envar, you start the serving, or maybe you start the web app, and then you can like mm, deploy separate nodes, right? And depending on what you use for deployment and infrastructure, you just have those two configurations. Yeah. Uh, yeah. So when it comes to like running out of VRAM, well, it depends. Like if you run a really huge model, then that's sort of inherent. Maybe the quantization would help that I shown in the article, but at the moment you still need to like load the whole model up front. So maybe you would like load the model first like onto the CPU and quantize it, save, and like persist. Uh, yeah, I don't have like any specific tips. It just really depends. Like if the model doesn't fit on a GPU, that's sort of game over almost. Uh, yeah, sometimes when you're like in a notebook, if you load multiple models, just keep in mind that like you're still sort of allocating the VRAM, right? So sometimes you just need to restart it and notebook, or comment out some of the other things. But yeah, does have we have multiple copies of the model in memory? Yes, we okay. This question is again related to the thing I showed with multiple compilation, multiple sequence lengths. So what happens is that we compile the model, uh, right? We have like four variants of the compilation, but the compilation it's not including the parameters, right? The compilation is like just sort of an executable, and it's not really huge, so it's not a problem. And the parameters are going to be reused for whichever version of the compilation we invoke. Right. So there is no much penalty, I think, for doing that. Yeah. Oh yeah. So how the distributed serving is usually done? Well, yeah, like we probably don't have like enough. I don't have enough data points on people running in production as to how it's usually done. It also like sometimes depends on the size of the model. Like if you have a smaller like embedding model, maybe it's fine to run it in as part of the web app. But if you want to split, then yeah, I would just have two separate nodes, and it's sort of up to you if you want to configure the same app using an envar again, or if you use like an umbrella to sort of, or even you could have two totally separate projects deployed separately, but still use distribution to communicate within between them, so we don't need to like have a API and all this stuff. Yeah, regarding like Apple, we are still like experimenting with running NX on Metal. I think there are like options to do it through Tortex, but through XLA, Paulo has this new effort of NX IRE, which allows it to like compile NX functions to executable and run it like on the edge, but in particular it also supports Metal. However, like some of the operations are still not supported, so we are still working this out. And there is another avenue option for Metal, which is like a sort of separate plugin that you would just configure the same way you configure to use CUDA, you would configure Metal. However, the plugin like is developed closed sourced by Apple for the JAX library, and it's like pretty slow in to resolve issues. I have like a PR on NX with a proof of concept, and I have like a whole list of issues reported upstream of things that would sort of need to get done for us to actually be able to reasonably use it. And so far, it's not being like addressed rapidly. So we'll see where it goes. We may have a better chance with NXIRE that Paulo is working on. Yeah. So the programming rendering D3 in Livebook. Uh, so you could do basically the same as we do with Vega Lite, for example, right? Where you can write your custom output, and then you can write it as implemented as Kino.js, which allows you to take an Elixir infrastructure, right, pass it to the client, and you can render it however you want, right? So you can bring in D3 and then have some API for, maybe you have like a declarative API for the three. Or if you wanted to make it like more imperative, you could use Kino.js Live and make calls to the Kino and handle the events on the client side and update the D3 charts. Yeah, which we also like support for Kino Viga Lite. It has like a live version where you can push new data points. So that's probably the closest thing to look at. There's also Kino map library, which is the same in the spirit, like on the way it works. So I would just look at this through for inspiration. But I think you can totally use D3 to do visualizations in Livebook. There's just no Kino available yet, but it's totally open for somebody to implement it. Unless GGML model for Bumblebee, no, currently no, because so I mentioned like there is a way to quantize the model, but we don't have ways to load those like already quantized models. So for that, your best chance is to like Llama CPP. I think there is an Elixir binding to Llama CPP. Yeah, so that may be your option. What about support for AMD GPUs? So technically we do support AMD GPUs, but you need to like compile XLA yourself. So like you look at the Elixir NX/XLA repo. There is you need to set XLA target to Rockham and have like all of the packages installed for it to compile. Uh, yeah, but the thing is that it's a little bit tough so far because the AMD GPUs have much sort of worse adoption. So working with AMD GPUs in Python, even like in the Python ecosystem, is quite painful from what I understand. It's like very, very second thought for most of the frameworks. Hopefully it's going to improve, but like we basically rely on upstream libraries, especially like the Google XLA compiler, to sort of fix bugs and make it work. Uh, yeah, that's pretty much it. Hopefully, it's going to improve over time, but I think it's also related to the fact that like AMD itself probably just like doesn't invest enough to try to address those gaps in the Python ecosystem, which sort of it's like a vicious cycle where oh the AMD is not that well supported, so people use CUDA and it gets better support and exposure. So yeah, that's kind of how it is. Who designs Livebook UI? We have a designer, Akash. So he usually like works when we want to implement like a huge new feature, or maybe like Livebook Teams. He helps to he does the design and we provide feedback, and yeah, that's how it's been like almost since the very early. The first release was already designed by him. So yeah, CUDA is a big dependency. Yeah, that's true. That's true. So actually, like in a recent release, I managed to change how we build the Docker images with CUDA for Livebook, in a way that instead of using the official images, we just now install CUDA and just like a subset of CUDA necessary to run XLA, and this allowed us to like build the CUDA on GitHub Actions because before the images were just like too big and GitHub Actions would run out of memory. So for past releases, I would have to like build all of the CUDA images sort of manually on a cloud instance with more memory. But yeah, CUDA is a little bit of a pain to get running. Yeah. Will there be functionality for highlighting a few cells in Livebook, deleting them at the same time? Uh, There are no plans at the moment, but feel free to open like a discussion for that. Uh, I usually just like use shortcuts for those kind of operations, which makes them pretty quick, right? Like for example, if you want to delete a cell, you just do dd, and you can do it a few times. And also you can like delete or remove whole sections of cells. So this is another way. We kind of don't have like a way to group, have like a group selection, but I guess that's something we could support. Yeah. Do you have any keynotes in mind? How about smart cells? Uh, Nothing particular comes to my mind. Well, like we just mentioned D3, right? So somebody could implement Kino for visualization based on D3. For smart cells, you could really take like almost any library that you like and has some API service and turn it into a smart cell. Because the whole idea of smart cells is to like make it easier for people to use a library that they're not familiar with, right? So all of the built-in smart cells that we have are to, show people like, oh, that's how you can use Bumblebee to run machine learning model. That's how you can do a remote execution, right? And so if there's like a library that doesn't have a smart cell and you think it would be worth, then yeah, go for it. Okay, I think I ran out of questions. Feel free to ask anything else. Thank you for showing up. Yeah, I think if we run out of questions, maybe it's time to wrap up. Unless somebody has more, really up to you. We can also like discuss, any implementation details or really whatever you want. Yeah, sure. Go ahead. Oh, if you remember a discussion, yeah, I don't remember where we landed. But yeah, like if you want to ask follow-up questions for the discussion, just feel free to come. Yeah, this one. Let me. I'm not tweeting. I don't use any social media basically, other than GitHub, I guess. But you can find me on Slack. The machine learning, sorry, the Erlang Ecosystem Foundation has Slack, and that's mostly when we hang out. There's like a machine learning channel for all the machine learning related stuff. And yeah, if you want to ping me, you can do it there. Email also works, very old fashioned, but yeah. So yeah, feel free to follow up on the discussion, and we can see. Yeah, GitHub is like Instagram for sure, especially like all of the followers and stuff. I don't read the feed though, so yeah, didn't get me there either. Oh, hello. Yeah, no worries. It's going to be uploaded, so it's fine, Mikkel. Strong typing and an X. Yeah, that's a very interesting question. It's kind of similar to like Ecto, right? Because NX is one huge macro and similar like Ecto. So I'm not sure if at this point like the Elixir team has like an idea how to do macros, but I mean I'm not like the person to ask really. So I don't think it's going to like change NX, right? But the question is like if we're going to have sort of strong typing for the dev ends, and I don't know the answer to that. It's probably too early to know the answer to that also. I am recording, so I think so. So hopefully that's going to work. Oh, I don't think there would be performing gains. So actually, how NX works, like if you have a dev end, right, and it runs, it it actually doesn't run the computation up front. At least when you use like a compiler, right? If you specify XLA as the compiler, what happens is that we run. You can think of it like tracing. So when we invoke the def-n, it first passes a sort of fake tensor, like an expression, and it builds a whole graph of the computation that should happen, right? And then it's going to be passed to a compiler, like a C compiler, very low level compiler that does a heavy optimization, produces an executable, and that executable, runs. So I don't think it's going to change the typing. Like it would not change anything in this aspect. Yeah. Yeah. Sure. Thanks. Cheers. Yeah. Okay. I think maybe the time to just wrap up if everybody's happy. Uh, okay, hold on. Okay, how do we decide which models support in Bumblebee? So basically, sort of rule of thumb and inherently what happens is that there is this library in Python called Hugging Face Transformers, and it's very much like we are mirroring that library. And so, for example, on the Hugging Face hub, the repositories, like if you look at the files there, they're all generated by that Hugging Face Transformers library, and they have like a particular format for the model description of the model configuration and the parameters, how they are stored. So basically, any model that is in Hugging Face Transformers is sort of good to be added to Bumblebee. And maybe like some models, well, also models in diffusers, the other library. But again, like this is a pretty much a whole separate area, which we're a little bit behind on, but hopefully in the future we can catch up on the image generation as well. But yeah, models and any of these libraries should be sort of compatible to be added to Bumblebee, and that's how we drew the line. And if there is no support for an existing model, what you can do? So there are a few things you can do. Probably the best chance is using Ortex. So when there's like a model, you can export it using Python into Onyx format, and this is portable for like a standardized format for describing machine learning models. And Onyx also has a runtime, so you can take virtual like any model and run it on the Onyx runtime. And there is Ortex in Elixir, which is like a binding to the Onyx runtime, and it also provides serving. So some of like the benefits of batching that are directly implemented in X, it also supports. And yeah, it also works with tensors, but basically it delegates all of the work to the Onyx runtime. So that's probably one of the things you could do. And if you're talking about like large language model, then maybe you can try the bindings to Llama CPP, especially like if you want to use some specific quantization techniques. Then yeah, Llama CPP is a great product. So uh, really efficient. So yeah, that I think are the best options. BirdNet, I'm not familiar, but it is like another LLM. It's not Big Bird, right? Is it just like LLM? Again, if it's implemented in Hugging Face transformers, then it sort of could be in Bumblebee for sure. It's just that it's a matter of prioritization. Feel free to open an issue or pull request, and we can have a look. Let me see. Scientific audio. Yeah, I would need to look closer, but basically, like try to search on Hugging Face if if it's supported in the transformer library. Otherwise, maybe it should be like a separate package or something. Do you see opportunities for Elixir ecosystem to live for Python? Uh, well, yeah. So it depends. Like as I mentioned before, sort of the underlying computation is similar. Like Elixir and Python, both of them are used as a sort of higher level language for delegating the work to a much more lower level efficient processing. So in this regard, it's kind of at best we are going to sort of be aligned, but there are definitely some nice things we could do with distribution, especially with training and sort of stability of the workloads. But yeah, it's kind of yet to happen. So one thing that Chris mentioned on the keynote is like all of the comment everything like I showed at the beginning, right? Like the fly runtime and then spawning like multiple machines with the GPU and having the parallel trainings. So that's for example like one example of something that it's like straightforward in the Elixir ecosystem. But in Python it would require probably like a few services, and it's actually still hard because like so on the keynote, what Chris did is started 64 machines with a GPU on each of them running a training of the like BERT model, and all of them were streaming metrics from the training to a chart in Livebook, right? And so normal like in Python, you would need a separate service for the charting, some cloud setup to do the have the machines, and then like manage dependencies, do the deployments, like a lot of factors to do this kind of training. So this like you can see that how this integration of different things in the Elixir ecosystem, different packages, uh, makes it possible to basically like implement all of this like tooling on your own, and it's not really difficult. So I think those are like the avenues where we can provide like more streamlined experience instead of bring your own library to do the thing, instead of having a lot of services for specific parts of the machine learning workload. So I think like on the higher level, on the orchestration level, there is definitely much we can do, especially with distribution. Oh, that's where the bird comes from. I see. There is like a transformer called Big Bird or something like that. So that's why I was confused. Big Bird, I mean, yeah, as a wordplay on bird, I guess. Uh, yeah, I haven't heard of this one. Uh, yeah, that's fair. Okay, I think we're good. Should I just like stop the stream, or do you want to say something, Michael? It's up to you. Oh, sure. Yeah, so I can just stop the stream. So thanks for everybody for joining. If you want to ping me or like ask more questions offline, just as I said, the Erlang Ecosystem Foundation Slack, or you can email me or open issue on the relevant project on GitHub, and I can answer that. Yeah, thank you very much, and have a great night.